For our experiment today, you will be doing a setup something like this. You will have a long necked round bottom flask in which you will have to put your boiling stone first. You will then add approximately 4 ml of the mixture that is provided to you. Remember, this mixture contains ethyl acetate and butyl acetate. The third step is to insert the copper packaging. The copper packaging will increase the surface area and cause little fractions to be collected, evaporated, cooled, and sent forward. A piece of advice that all of you must follow is your thermometer's bulb should be aligned properly to the lower side of this side arm. So if your thermometer is placed too high, if the temperature bulb is up high, you will record decreased value of your boiling points. And if you place your thermometer too deep in the flask, you will have a higher value of the boiling points. Boiling points higher or lower than the actual value. So make sure that your temperature bulb or thermometer bulb is placed at the right location. Make sure that your setup is upright. It's not leaning towards you or on the sides or on the back. Always place a tile, a small insulation tile between your sand bath and your side vial. Today we have 2 materials, so you will be getting at least 3 vials. Make sure you label all of them. You will see that the liquid starts to rise from the top and cools up here, becomes liquid again, and drips down in this vial. The moment the first drop comes in, you will read your thermometer. And you will start to record each of these temperatures in your notebook. So for this purpose, you can leave a page or so also, or on the same page, you can make separate columns to record the temperatures and the drops. So do not interrupt the drop number. Let the numbering be continuous. So 1, 2, 3, 4 up to 15 or 20 or 25, it does not matter. As long as your experiment is going on, you will keep on writing these drop numbers and their corresponding temperatures. You will have to circle or mark those drops at which you have switched the vial. Now, ideally, you should have obtained a graph like this, and this is a graph that you will have to draw. But what is happening to a normal or typical student would be that you will get a graph with many dots up and down. The lower plateau indicates the boiling point of the lower boiling component, and the higher plateau indicates the boiling point of your higher boiling component. When you will be drawing your graph, you have to draw or spot each of the drops. And you may get a real life graph If you see, all of these dots on my graph are also not consistent. But I'm not going to draw a line like this. That would be wrong. Do not join all the dots. What you must do instead is remember your GChem 1 and draw a smooth curve. So that for your data sheet, you can figure out the boiling points of both your materials, the corresponding temperatures for both the plateaus. So this is the smooth curve that all of you should be drawing out and not joining your dots. You also need to indicate both the switches. And make sure that you have labeled your axes correctly. When do you have to stop your work? When your mixture is 1/10 left. What does this mean? If you're about to run out of your solvent or your mixture, you must immediately rise or raise this experimental setup out of the sand bath so that no more heat can reach this leftover solution. Esters, when heated, become peroxides, and peroxides, when heated, become detonated. So you can get an explosion in your fume hood. So this is your priority. If you have sufficient solvent going on, then you need to get 10 consistent numbers. The 10 consistent numbers just indicate that you have reached towards the end. How do you decide which numbers are consistent? They should be very close to each other. They don't have to be exactly same, but close to each other within a decimal place. And so on and so forth. When you have finished with your experiment, you will wait for the setup to be cool before you actually take it apart. Make sure that you have plugged off your sand bath and raised the setup. You have to go in the instrument room. On your machine, you will first collect the RI of the water so that you can calibrate your machine. You also have to take the refractive index for your both the first and second vial and the last vial or the round bottom flask itself. You will use the calculations that we discussed a few days ago while we were doing the GC and the RI, and you will be doing these in your data sheet as well.